Okay, hello. So today what we'll do is actually the Hua Chong promo. Okay, one thing why I'm doing this is because actually many students, they also ask me basically when I do A levels every year, I post the answers. What goes through my mind, how do I do the A level on the spot, and what am I thinking? So just nice, I think the Hua Chong promos also happen to have a bit of difficulty this time, according to the students. And they also ask whether I can actually share how the whole thought process is done and how we can better improve basically the meta-cognitive or heuristics part about solving a math paper. And actually, I let some of the J2 try the promos. I think the questions overall are essentially good. They help students to think a bit. There are also some questions that are from the A levels or similar to it. So I thought it's a good exposure for JC2s. For the JC1s from Hua Chong, I mean, get a paper back today, I think. I'm hoping you can benefit from this by understanding how you can think through the paper, approach the paper, and ultimately H2 math is all about problem solving skills. So when we look at the paper, how we strategize, how we actually start by solving certain things, it's something that you need to build up along the way. And it's not really just grinding A-level papers and papers meaninglessly or just going through questions. The concepts are actually quite important when it comes to problem solving. Yeah. And also for, of course, this is a Hua Chong big promo lah. So it is for non-Hua Chong students, the goal here, I mean, if you want, you can go and try. The paper is here. I can't really share it. But you can always pause the video before you do the questions. Then you can review lah. See if we went through the same kind of thought process, the same mechanism. Personally, have I done the paper? I did honestly look through the whole paper, and I did actually try some stuff just to get a gauge of it. Sitting down and doing a full paper for 3 hours, not yet. I usually do that only for A levels as a student. So today what I'll try to do is I will try to actually just experience the paper, and yeah, you can see how it goes. But maybe one thing just to be clear, this is not meant to teach the topic. So it's not very instructional. So maybe in these 3 hours or even less, you'll see what goes through my mind when I go take A levels every year. What's the first things that I check for, and also hopefully this will strengthen how you tackle papers. And for the JC2s that I gave this paper out for you guys to try. Hopefully you should be able to do the full paper within the 3 hours. After all, it's a J1 paper, so to speak. And other things also, because this video that I'm taking and this paper itself is a very raw video, probably not edited at all, and I will not be editing it. So you will definitely see a good number of maybe mistakes or careless. Maybe I probably wouldn't even get full marks actually. I don't know. So we'll see how it goes. Yes. So, but at the start of the paper, usually what I'll do is, it's funny, but I actually will pretty much read the instructions. Okay, it's actually quite important because you never know which day they change it. So usually what I'll do is I do read that it's 3SF, it's 1BP, etc. Things that I want to know. I think for Hua Chong paper, this one, they're also quite nice. They actually gave students the question number. So the scary part is there's clearly 13 questions. I think that's one thing that stood out for me when I do look at the paper. So yeah, you probably need to take note of this. Usually at A levels, I always tell students, you check through the paper, find out how many questions you have. It's important because if there's a lot of questions, you need to plan the time. So if you ask me, when I look at these 13 questions, probably I'll take about 1 hour here. I'll probably take maybe another 1 hour as a student, right? As a student, I'll probably do this, something like this, probably need 1 hour here also. So, and if you go and check, usually you probably wouldn't pass. Like what I told some students, you don't pass even if they finish the first 7 questions. So actually, before the start of the paper, it's extremely crucial that you gauge how it goes. And yeah, so without further ado, I will start the paper and I'll try to finish in 3 hours. And yeah, hopefully I don't need toilet also, right? Okay, then let's begin. All right. So the first one is on inequalities. So standard work, we will bring over everything. So you bring everything over, we have this over 2x minus 1 less than or equal to 0. Now if we solve this, this is 4x squared minus 12 plus 3 over 2x squared minus 1. So this is 4x squared minus 9 over 2x minus 1. It's quite different to solve on the board actually. Wow, okay, anyway. So we have 2x minus 3, 2x plus 3 over 2x minus 1. At this step, of course, we may consider the number line, right? And then we have that this is actually half. This is probably 3 over 2. This is negative 3 over 2. And then we have a plus minus situation, right? Therefore, we have that x is actually less than or equal to 0, less than negative 3 over 2, or x is between half and 3 over 2, equality sign for the numerator. And then we check, and then that's all. Now, of course, if you want to check using your GC, you may. Usually what I'll do is, if I'm a student, I'll usually check with GC. I'll secure marks before even going to the next part, because there's no point in me getting the next part correct, but my first part is wrong. I probably can't solve the question anymore already. So I'll check usually. So I graph and I get this. I probably can gauge that it's less than or equal to 3. And I am correct because less than or equal to 3 means that there's this part and there's this part. So it should be half and 3 over 2. That's good. Okay, now next part, this EX, we probably replace X by EX. Now, we'll have EX less than or equal to negative 3 over 2. This one we can reject since EX is positive. This is half less than EX less than or equal to 3 over 2. Now, we call that ln is increasing, so we can just ln both sides. And we are done, right? Okay, moving on to the next one. Okay, it's 1, 1. 1, 1 means horizontal line test. Now, this one is reduced graph. We look at the graph, we have, okay, F mod X basically means that the reflection about Y-axis. So this part is out. I'll focus on this. Since the graph is 1, 1, this part is out. I only have this. So if you want, we can give a quick scribble, right? Graph itself, something like this. This is my fx. Okay. Now state the range of values of x for which is less than equals to 0. Less than equals to 0 means it's below the x-axis. So we have x is between 2 and 0. Now, because there's equal sign, we equal to 0. Great. Now, asymptotes of the graph of 1 over fx. We know that intersections for x is asymptote. So that would be x equals to 0. And of course, y asymptote, y equals to 1/4, right? Right. Now for this, we have a ln graph. It does not have an inverse. Look at the marks, it's only 1 mark. I probably don't want to draw a graph, waste of my time, right? So I would probably be suggesting maybe h of a number. Judging from this, because it's quadratic, I guess a good number would be 4. Yeah. And we do h of minus 4. Now then, sorry, calculator. So 3 times 4 square minus 9. Why I picked 4? Partly because 4 and negative 4 is out of that range there. So ln 39, ln 39. You can pick any number so long as you match the domains. So it's fine. Okay. Now, so we can explain that h4 equals to h minus 4 equals to ln 39, 4 not equals to minus 4. And then we explain that for h is not a 1, 1 function. Therefore, h does not have and inverse. You may do horizontal line tests, but 1 mark, not worth it. Now, the graph is being restricted. In this case, I might have to draw the graph. It is ln of, okay, so I'm going to draw the graph first. It is ln 3x squared minus 9, sorry, 9, divide bracket, x is actually less than, conditions, x less than would be actually 2, x less than negative square root of 3, logic, or x is greater than square root of 3. Okay, that was a lot of time. Okay, so if I graph it out, the graph is this, is the graph. Okay. Now, they are interested in -3 to lambda. So -3 would be somewhere here to lambda, such that it's 1, 1. Then lambda should be negative square root 3. Right? That should be the largest value. Anything beyond is not 1. Okay. Now, use the value found. So I'm going to restate my hx. My hx would just be ln of 3x squared minus 9. Sorry, I've got -3 to negative square root 3, -3, negative square root 3. Now, h inverse, we'll simply let hx equals to y ln of 3x squared minus 9 equals to y. 3x squared minus 9 equals to ey. And 3x squared, let's skip a bit of step. X squared equals to ey plus 9 over 3. X is equals to plus minus square root ey plus 9 over 3. Okay, now x is actually from these values. So we take x to be negative plus 9 over 3. Common error here might be forgetting to change the y back to x. So just be careful of this. Now, domain of h inverse will be the range of h, which from the graph, it is basically from 0 to 2.89. They don't want exact, so I'm just going to go with 2.89. So 0 to 2.890. So 0 to 2.89. Sorry, 0 to 2.89. 2.89 was given when it's -3, so it's inclusive, and this should be exclusive because it's excluded. Right? That's all. Find the set of values h inverse hx equals h inverse x. Well, we know that this is actually, just allow me, I can teach you a bit. This part here, they are both equals to x. Recall this is domain h. Recall this is domain h inverse. Now, equals means that they intersect. Then if they intersect, means that we want domain h and domain h inverse to intersect. Domain h is actually from -3 all the way to negative square root 3. Domain h inverse is this, so they actually don't intersect. Basically, you can say that it's empty set. Right? For this one is a very typical A level. Yeah. Okay. Okay. Anyway, so we have that this is width equal width. Now, since there's only one unit, and then they are drawing n rectangles, we can get that the width is 1 over n, right? So usually what I'll do here might be to model out a bit. Okay. So the first thing is that the y coordinate is 1 over n. This is 2 over n. Then this is 3 over n. This last one is n minus 1 over n. So usually what I will do, or rather what I'll tell students to do actually, is no need to be shy. In fact, write out the coordinates. So if your y itself at this point itself, right, just write it out. This point itself, the coordinate happens to be 1. right, comma 0. Okay, this one on the other hand, the y itself, okay, the y, okay, I'll just write the y here. So the y itself is equal to 0. At this point itself, the y is 1 over n. So my x coordinate would be 1 over n squared plus 1. This x is 0 over n squared plus 1. This x itself is 2 over n squared plus 1. This x itself is n minus 1 over n squared plus 1. Okay, this should be the things. Okay, I need. So the area of AN itself is the sum of all the rectangles, I guess. Right? AN itself is all the rectangles and the arc, right? So in a sense, I will have that the width is consistently 1 over n, length of breadth, times 0 over n squared plus 1 plus 1 over n, 1 over n squared plus 1 plus 1 over n, 2 over n squared plus 1 plus etc. until 1 over n, n minus 1 over n squared plus 1. Right. So we are trying to observe the APGP pattern out here, of course. 1 over n can be factorized out. Notice one thing is this is 0, this is 1 to n minus 1. So I'm going to just wrap it up and say that this is r equals to 0 all the way to n minus 1 with r over n squared plus 1. Right? Probably something like that. Okay. Now, of course, I need to solve this further to show that weird looking thing. So this is 1 over n, and I have n minus 1, summation r equals to 0. This one is r squared over n squared plus n minus 1, summation r equals to 0. This is 1. Okay. And we have that this is 1 over n. This one I can adjust it a bit. Actually, we'll observe when r is 0, we get 0. So we have n minus 1 is actually the same thing. So this is just r squared. Put 1 here. This r squared plus this one is just n. Right? So if I expand, this is 1 over n cubed. Oops, sorry. R squared summation, the formula is given. Okay, so n minus 1, n minus 1 plus 1, 2n minus 2 plus 1 over 6, okay, plus 1. Okay, right. Oh, that's the one there. Okay, great, fantastic. Right, I just need to simplify this. So this is n minus 1. This is n. This is 2n minus 1 over 6n cubed. Okay. Great, I'm done. Okay. So this is actually n minus 1, 2n minus 1 over 6n squared plus 1. Fantastic. Okay. Now, show the exact value. Actually, this one has many ways of doing it because if n goes to infinity, well, we know that an itself is 2n minus 1, n minus 1 over 6n squared plus 1. I guess there are a few ways. If you really ask me, okay, if I go by my understanding, I can always integrate. If not, actually, if I expand, this is 2n squared minus n minus 3n plus 1 over 6n squared. So of course, we cannot say n go to infinity here because it's quadratic and quadratic. So probably what I can do next is I long divide a little bit to 6n squared. I will put 1/3 here, and this will be, okay, this is a while. Okay, so this is done. Minus over, and this is minus 3n plus 1. Okay, good enough, right? So my an itself is 1/3 plus negative 3n plus 1 over 6n squared plus 1. Actually, you know what? That was stupid. I could have just split the fractions up to just 2n squared over 6n squared minus 3n over 6n squared plus 1 over 6n squared plus 1. Yes. This is 1/3 minus, yeah, this is a bit nicer. Okay, and this is a bit nicer. Was a bit not very smart on me. Okay. So 2. Okay. So of course, if n goes to infinity, we find that this is all going to go to 0. My an actually goes to 1/3 plus 1, which is 4/3, since 1/2n goes to 0. And 1/n squared goes to 0. But this is not the best way of doing. The best way might be that we integrate. So, because this is going to give us the actual area from 0 to 1, right? Y squared plus 1, 0 to 1, y squared plus 1, dy. If we integrate this, this is 1/3 y cubed plus y, 1, 0. This is just 1/3 plus 1. So this is a better approach. I'll say this is a better approach. 1 is boring. Okay. Now 5, we have vectors. Okay. Right. Now good news is this is given in vectors. Notice the vectors. So since it's vectors, we have 2pq equals to qr. Now if this is the case, then go back to basics. OQ minus OP equals OR minus OQ. Right, that's all. And I just rearrange a bit. I get that 3OQ, right, equals to OR plus 2OP. Right? Okay, so OQ would just be 1/3 R plus 2/3 of P. Yeah. Okay. Right, for the perpendicular scalar product, find OF. So F is on Q. OP, right? So OF is equals to lambda P for some lambda. So QF itself is lambda P minus Q. Right? Then after that, QF dot P must be 0. Right? This is the scalar product. Okay? Lambda P minus Q dot P equals to 0. Then we have lambda mod P squared minus Q dot P equals to 0. Q. Q is 1/3 R plus 2/3 P. So lambda mod P squared minus 1/3 R plus 2/3 P dot P equals to 0. Okay, running out of space. Is there more space? Okay, thank God. Okay. Now lambda mod P squared minus 1/3 R dot P minus 2/3 P squared equals to 0. Lambda mod P squared minus 1/3 R P cosine theta. Right, we have something there. R dot P 45th. Okay, so OR is 3OP. OR is 3OP. OR is 3OP. So I have 3OP. And this is OP. This is 4/5 minus 2/3. OP squared equals to 0. Right. And of course, we can cancel some stuff. Right, something like this. And Q. Okay. We have this, and then we have cancellation, and then we have this. And then lambda will be 4/5 plus 2/3. 4/5 plus 2/3. And this is 22. Wow. Okay. So OF is 22 over 15p. Okay, so OF is 22 over 15 modulus of p. That should settle this part. So, okay, because the answer is a bit weird, so let me just check a bit. OR is 3 of OP. So lambda QF is at dot P X and blah blah blah. Everything's negative. Okay, okay, but wrong, I'll come back later. Right, determine if it's on the line segment OP. Now, since OF is equals to 22 over 15 of OP, it is not on the line segment. It is actually produced, right? F is on OP produce. Okay. Right. Okay. Bit slow. Okay. Now 6. Now this one. Okay. Piecewise. Okay. Gotta use piecewise. Piecewise. So yeah, like this, which is good. Cosine x over 2. 0. Second f. Conditions less than equal less than y must be 2 pi. 2 pi less than equals less than, right? Yeah, conditions. It's 3 pi. Okay. Yeah. Okay. 2 over pi x. Okay. A little bit underwhelming. Right. Right. I'm going to just cut off my graph a bit. Negative 4 to 4 probably. Okay, so we have a line and a curve, and I'm guessing if I calculate the value for 2 pi is at the kink area. Yeah, it's 2 pi and negative 1. Okay, so and then at the start when x is 0, it's 0 and minus 1. So 0. Okay, this is 0. Is it inclusive? This is 1. This is probably, where is pi actually? Pi is at 0. Oh, I need to draw it a bit more symmetrically. It's probably pi. This is 2. They want what? They want, oh, they want 4 pi. Yeah, I'm going to draw it even smaller. This is pi. This is 2 pi. And then I have a 3 pi. 3 pi is going straight up. So I have to calculate when it's 3 pi, it's probably 1. So this is this way. Yeah. Okay, that's fine. And then this is negative. All right. X plus 3 pi. So every 3 pi I repeat. Okay, can I can do that. I need 4 pi, so I just need to go down. Okay. And this is an open circle, right? Okay, this one must come down. Negative pi 2. Negative pi 2, I probably need to calculate what value it is for 5 pi over 2. Just check it. 0. Mistake, so I just need to come down a bit. This is inclusive. Right, so this is negative pi 2. I think that's all. Endpoints, there's only 2 endpoints. Okay, we're done. Okay, oh, nothing else. Okay, fantastic. B. All right, find the area of the graph. Okay, area of the graph of the everything basically, right? So actually the area of the graph are bounded by curve and the x-axis. So they are looking at 1, 2, 3, 4, 5. Okay, pardon me, but I'm going to just use a bit of highlighter. So you notice that this area here, this area here, this area here are the same. Also notice that this area here, this area here, this area here is the same. Easy, right? So we integrate from 0 to pi, right? For cosine x over 2. Dx. And because I have 3 pieces, I times. Right? Right, plus, I'll just use triangle. Negative pi 2, this is 1. So negative pi 2, so pi 2 times 1, half base, right? Half times pi over 2 times 1. And I have 1, 2, 3, 3 pieces, right? Times. I'm done. Okay, great. They want answer in some pi. Kind of cheesy. Okay, anyway, I can integrate this. So sine x over 2 over half, right? Pi 0. Sine 0 is 0, sine pi 2 is 1. So this is 2 minus 0 plus, what is this? 3/4 pi. This is plus 3/4 pi. So that done. Okay, that done. Yeah, I'll check my answers because I'm very insecure. Okay. 0 and pi cosine x divided by 2 dx. Okay, it's 2. Then this, oh, I forgot my 3. That explains. Okay. Okay. So this is 6. Okay. Check. That's all. Sine square. Double angle. I got MF26 somewhere. Where's my double MF26? Sine square. Right, sine square is what's 2a? 1 minus 2 sine square a. So cosine 2a, it's 1 minus 2 sine square a. Frankly speaking, I mean, there's really no incentives in memorizing. It's exams, panicking, no point memorizing stuff. Just do, right? Know what to do. There's enough time. Right, so we have half of theta minus a quarter sine 2 theta plus, I mean, if you want, of theta minus 1/8 sine 2 theta. Simple. Wow. Okay. We have to use, wait. Okay, so C1 is y equals to sine inverse x. Why do you give me y for? I want to integrate y. If I integrate y, would I be using the sine inverse? Or I have that x is equals to sine y. C2 itself is y, oh, there's no y, y2. It's 2y equals the sine inverse x. Probably change it also to sine pi 2. So x equals to 2. No space. They don't have to mark that much. It doesn't matter. Okay, so I want this area. I mean, considering part A, I probably want to use sine squared. So I probably do this. Okay, B is given to be pi 6. Okay, and this is 0. Okay. They want the volume generated about x-axis. No, it's bound completely about the y-axis. Oh, great. So it's okay. T2 minus C1. Okay, so the volume itself would have been pi, integrate from 0 to pi over 6. So it's the outside one. Outside one is C2. So that will be sine of pi over 2 minus 2y square minus sine square. They say using integration, so we must integrate. We can't use GC. Oh, there's space below. I need the space. Yeah, right. Well, we did integrate sine square just now, although I'm not sure if the replacing is so straightforward. So I'm just going to play safe and I'll just do it again. Never mind. This will be 1 minus cosine 2a, so it's pi minus 4y over 2. This is half the 1 minus cosine 2y over 2 dy. Just play it safe. So this is pi. If you integrate this, I guess the half and the half will minus each other off. So you have negative sine pi minus 4y over 2 times negative 4. Then this is plus sine 2y over 4. Okay. And yeah, I can just solve this. All right, so this will be equal to pi. Wow. So much work. Sine pi minus 2 pi 3 plus a quarter sine pi over 3 minus, so 0. Okay, so we have this sine pi over 3 or sine pi over 3 sine pi over 3. That's sec 3 over 2. So 1/8 sec 3 over 2 plus a quarter sec 3 over 2. Okay, so 3 pi over 16 sec 3. 490. So I'm going to check. I don't feel safe with this. Okay. Right. Pi. Right. Math. This is 0. This is pi over 6. This is sine pi over 2 minus 2y squared minus sine squared. Oh, I don't feel good. 3 pi times. Oh, that's correct. Great. Oh, fantastic. Units. Actually, you notice we check a lot actually. Yeah, I'm still too slow. 8. Convergent GP. Okay. Now if it's convergent, what? Wow, that's weird. Okay, anyway, the ratio is given to be negative a over 1. So sum to infinity, convergent, modulus a. Convergent would tell me that I need modulus negative a less than 1. A is between 1 and minus 1. Right. Sum to infinity itself is 1 over 1 minus a. Not more than 5 is less than or equals to 5. Okay. This can be equals to 5. And we have this. A is real. Wow. Why you do this? So I'm going to rearrange this because I don't know if A is positive. I can't flip it. So 1 minus, actually I can use GC for this. Okay, but never mind, since I've already 5, 1 plus 8. I'm almost done. Right. So I have a minus 4 minus 5a. Okay, 1 plus a less than or equals to 0. Set phase. -1 and 4, -4. So -1, -5. It's here and it's here. So a is less than -1, or a is greater or equals to -4. So if I combine my answers, my a would just be between 1 and 4/5. Okay. It's quite stupid that I solve by hand. I should have just keep in 1 divided by 1 plus x, and I'm done. Right? I could have just done this, and zone 6. I could have just calculated the intersection. -4. We're gonna answer much. Yeah, okay, never mind. Waste my time. Okay. UN is this, Tn is this. Right. Justification means I need to use math. Still incorrect. I mean, if I take W1 is U1 plus T1. This is equals to 1 plus 1. That's 2. So here's correct. W2 is U2 plus T2. It's minus a plus a is 0. He's wrong, right? It's not equals to 2a squared. Right, so therefore not correct. That was okay. Right. W2n plus 1 in the form of PAQN. What is UN? Okay. UN itself is equals to 1 plus negative a n minus 1 by formula. Pn itself is same thing, but it's positive. Wn is un plus tn. So Wn is equals to this 2 added up. Why am I writing the 1? So stupid. W2n plus 1 would be minefield of careless mistakes. Okay. Right now, 2n plus a 2n. Okay. Fair enough. No space. There you go. Okay. Yeah, I ran out of space. It's quite interesting. So this is a2n plus a2n. Okay, right here. So therefore, it's equals to so W2n. I already run out of space, so this is quite easy. So therefore, P is 2, Q is 2. Okay. Okay, interesting. Okay. Weird. Whatever. Okay, 9. Integrate this. Right. F times x. Okay. So this is from secondary school. Right, it's 2 minus x minus half plus 1 over minus half plus 1 times -1 plus 2. Okay, I'm done. So this is square root of 2 minus x. Yeah, this is probably half times -1 versus -2. Just check calculate. 1 divided by half. Right. That should be it. Weird that this is 2 marks and that was 2 marks too, but never mind. Substitution. Okay, so we know that substitution, we can straight away differentiate this. I'm going to go straight for the 2u du dx equals to 2. Okay, so negative 2u is dx. Okay. So integrate x square root 2 minus x dx will be equals to, right, this is 2 minus u squared. This is square root of u squared. Dx itself is negative 2u. Right, let's integrate negative 4u plus 2u cubed. This is u. This is du. Okay. Okay. Just check. I don't want to careless mistakes here. So it's so many u's. Don't check. I might end up with u. Right. If I integrate this, this is negative 4/3 u cubed plus 2/5 u5. But this is very similar to one of the others. Negative 4/3. Now the u itself is 2 minus x, so 2 minus x to the power of 3/2 plus 2/5 to the power of. Right, that's about it. I don't think I want to check. Okay, how do I can? By parts. Whoa, it's hence. Thank God. Okay. How do I hence this? Never hence this. Okay. Right. I would integrate. Okay, so I'm going to just split it up this way. So I'm going to just write it in this way. Okay. And I'll choose to integrate. Okay, since I have that guy. Okay, I'll integrate this. Okay. So integrating 2 minus x minus half. Oh, that's right there. Okay, saw it. Okay. But then, do I want to even use it? Negative 2 square root 2 minus x. Negative square root 2 minus x times x squared minus integrate negative 2 square root 2 minus x times 2x. Okay, negative 2x squared square root 2 minus x plus 4 x square root 2 minus x. Yeah, I'd rather do this myself than use the product parts. Okay, but then, man, so long. Negative 4/3 over 3. Yeah, we can just 2 minus x 3/2. 2 minus x 3/2 plus 2/5. 2 minus x 5/2. Okay. What's that? No, it's not right. Okay. Can I simplify this? No, I can't. I can just expand a bit. Okay. So negative 2x squared. Yeah. What can I simplify this? Square root 2 minus x plus minus 16. Actually, I think I can actually simplify this, but 2 minus x 3/2 plus 8/5 2 minus x 5/2. I'm gonna check. Right, I'm gonna just check. It's too much work, and it's too much work, and it's too much marks involved. I'm just gonna throw in limits in. Usually in exams, I always tell students, you know, if you have time, you check. You invested a good 10 minutes on this question. So you invested 10 minutes on this question, you know, just check, you know, this is fine. At least it gives you confidence. I got 0.3000. So if I were to put this into limits, right, I would have a case whereby it's -2 times 1 times 1. Okay, actually, I don't have to. I just could. If I put 1, right? If I put 1, it would just be -2 minus 16/3 times 1 plus 8/5, right? And I minus away. I put 0. If I put 0, the first term is 0. Second term is 16/3 times 2 to the power of 1.5 plus 8/5, 8/5 times 2 to the power of 2.5. Actually, the thing is, it's about risk mitigation. So you see, in this case, I know I'm correct. If I'm correct for this, it's 3 marks, it's 5 marks, or whatever. Right? So you get some marks, at least you get like 8 marks for sure. So it's good to check. Of course, don't pick numbers like 1 million. Pick simple numbers. Be kind to yourself. Right? Question 10. Okay. Right. This club. Very standard A-level questions. Okay. So I have y equals to ax plus 2a over x plus 1. Now, I always tell students, you should always try to observe certain things. So to be honest, this question itself, if I have a bit of time, I barely took 1 hour. So if you observe, it's actually this particular expression. You could have done it much easier. A was just a distraction. The A-levels, I think last year they had the same thing. There was A there. So the students actually factorize it out. They probably observe a much more neater solution, but it's okay. I'll take it as I never see it. So I'm just going to use this first, and I multiply it together. So if I cross multiply this whole expression, this is ax squared plus ax plus 2a. Because we are looking at discriminant, so ax squared plus ax minus yx plus 2a minus y equals to 0. And our discriminant will suggest that a minus y square minus 4 a to a minus y is range for points on C, so greater equals to 0. Right, greater equals to 0. Okay, and we solve this. A squared minus 2ay plus y squared minus 8a squared plus 4ay greater equals to 0. Okay, just stay a bit calm. Just no careless. Plus 2ay minus 7a squared. No. Man, they give me not nice numbers. Do I have characteristics? Let me check. I can just check my answers later. I'll just check my answers later. I don't think this is factorizable, so unless I made a careless mistake. Do I have the careless mistake is plus? Then I have both as plus, got the question correctly. Wait, let me just check. Okay, so if I plot the graph out, this is x plus 2. So I don't feel safe with this. So usually I'll check it. Find my minimum point. Some horrendous fractions. Great, it's a horrendous fraction. Okay. Okay, I guess I have no choice. I have to complete the square. Okay, that's painful. Right, a plus. Okay, there we have it. And this is y plus a minus 2 sub 2a. Thank you for making it so complicated. Okay, you have something like this. Right, and of course it's happy face, so therefore That's y. So my y for my face. And we have greater or equals here, right? So y itself, this would be a minus 2 square root 2a. This would be a plus 2 square root 2a here. And therefore my y is less than or equals to this. Or okay, I'm done. Right. Range of values in this. Okay, great. X coordinates of the turning point. Oh, differentiation. Why differentiation? Okay, I'm going to use the green one that I have here because it's easier to differentiate without the a. I love a's, but x plus 2 over x plus 1. Okay, y, what? Space so small. Okay, great. X plus 2 over this is x plus 1. Okay, space is ridiculous. Right, it's fine. Okay, we can work with this. In which says we can work within the space. So I shall work within the space. Right, I'm going to let dy dx be 0. And then I have x plus 1. I'm going to skip a bit of steps simply because they said I can, it's 2 marks and I shall work with space. Okay, we have this. So x is equals to plus minus square root 2 minus 1. So that's the x coordinates actually. You don't have to find the y, partly because they didn't ask for it. And in fact, the answer is right there. You see 4.14, right? If I hit the x out, I believe it's the same as this because if I key in square root 2 minus 1, I get the same answer. So fantastic. I was correct. Should probably verify the y since I'm already actually at this. Yes. Minimum, just now I found the minimum. It's here. And then this 1.828. Right, 1.828. Do I have a negative 1 plus 2 square root 2? Yes. Okay. So 1.828. That's correct. Fantastic. Right, draw the graph. Okay, so since I already observed this y equals to a bracket x plus 2 over x plus 1, okay, asymptote clearly is x equals to negative 1, and the shape is actually from the GC. If you notice, it's the same graph. What A does, A just scales the graph, right? Make it fat, a bit taller, shorter, so I just copy whatever I see on the GC. It's the same thing. Just make it a bit higher and all this. So it shouldn't affect much of my drawing procedure, I think. So I'll just use whatever I see on the graph. So maybe some verification. The minimum just now was actually here. So it's to the right. So I'll just okay. Okay. Maybe I'll just adjust this a bit of it. Okay, okay. I mean, if in an exam you probably have a proper pencil, you won't be using a marker and write this. Okay, so this one I probably need to draw it this way. Okay, right. What do we want? Stationary points, asymptotes, intersection. So I only have one intersection, which is here. That would be. You can actually calculate everything. Multiply by a. This is 2a, right? So this is 0, comma 2a. This one, as I found it just now, is square root 2 minus 1, comma. The y is basically what I just punched in the calculator, right? So it's just negative a plus 2 square root 2a. It's negative a plus 2 square root 2a. Oh, actually, it's been a long time since I've really played the papers. Okay. Negative square root 2 minus 1. So this is negative square root 2 minus 1. The y is actually negative a minus 2 square root 2a. Negative a minus 2 square root 2a. Okay, I think I've got everything. Great. Move on. I'm pretty sure I'm correct because GC says so. Okay, and it's a fixed. Okay. Wow. So we have implicit x squared, a bit tired. Xy plus y cubed equals 16. Differentiate this is 2x minus x dy dx minus y plus 3y squared dy equals to 0. Right, rearrange. Okay, I should get the answer. 3y squared minus x dy dx is y plus 2x equals to 0. One more time. Great, 3 marks. It's kind of them. Okay, so 3y squared minus x d2y dx2 plus 6y dy dx minus 1 dy dx minus dy dx. 2 equals 0. Wow, so nice. How much? 3 marks. Right, so 3y squared minus x d2y dx2. Okay, this is for 3 marks actually. Because it's just techniques of differentiation. And I think if you couldn't do it, it's a bit wasted. Right. Yes. Oh, I forgot my square. Oh no. Lucky. It's true. Right. Moving on. See, area is 2y. So basically, OMY is this. Right. So it's half base height, I would presume. Okay. So one is, I need to find the coordinates now. So if that's the case, I can let the y be 0. If I let y be 0, so we can let y equals to 0. If I let y be 0, I would find that x squared equals 16. X is equals to plus minus 4. Right? So this is minus 4, and this is 4. So this would be 8 units, right? This would be 8 units. So this 8 units, I am done because half base, right? So this is y. Right? So area having half times 8 times y. Is it? What do you want? OMY. Oh, sorry, that's not. Okay, so it's half times 4 times y. So it's 2y. Okay. All right. I don't have to use that. Okay. Hence find x for which A has a stationary interchange. Oh, they didn't ask me to use calculus, so now A has a stationary value. What is A? It's 5. A is okay. So if A has a stationary value, A is equal to 2y, then the A dy is equal to 2. Okay, strange. This. So I know that 3y squared minus x. If dA dy is, you think of it. Then y. Something so if that's the case, the value of x, for which A has stationary value. If dA dy is 0, it wouldn't make sense. Yeah. What if I don't do this? What if I differentiate with respect to dA dx? Then I have 2 dy dx. If I have 2 dy dx, I can put it in here because m is a variable point. Stationary means dA dx 0. then my dy dx is 0. Okay, because 2 cannot be 0. Dy dx is 0. So if it's stationary, so A is stationary. I'm just going to try. If I don't do this, then the A dx is equal to 0. A dx is 0. Dy dx is 0. This is probably one question I need to think of it. Well, more time. Okay, dy dx is 0. Then I substitute it in. Then I have negative y plus 2x is equal to 0 because the front part is 0. Okay, so in this case, y is equal to 2x. Okay, so I can, if y equals to 2x, I can put into a curve x squared, xy, and y cubed. So x squared minus xy. So minus xy plus y cubed equals 16 plus y cubed equals 16. Okay, let's see. Negative x squared plus 8x cubed equals 16. Okay, 8x cubed minus x squared minus 16 equals. I'm going to use a GCMC. Oh, that's not exact, right? Okay. X 9 over 3. Next, what do I have? 8 minus 1. 8 minus 1. It's scary. Minus 16. Very correct. Oh, 1.3. There's only one answer. So using GC, x equals to 1.3. No fractions, right? 1.302996. Okay. Then my y would just be equals to 2 times 1.302. Okay, this question is a bit hard. 2.60599. 2.60592. This is difficult actually. Okay, anyway, x and y is found. I do need to verify d2, so I probably will have to put it into here. Actually, since my dy dx is 0, should be quite straightforward, right? So we have that 3, so 3 bracket 2.605992 square minus x minus 1.302996 d2y dx2. Now we do know that dy dx is 0. Okay, I guess means that is that point here. It doesn't matter. Then this is 0. This is 0. Then I just need plus 2. That's your point. So there's a plus 2 equals to 0. You can find d2y dx2 value. You probably can't do the first derivative for sure, actually. Not very feasible. So 3 times answer square minus 1.302996. Right? Okay. This, so negative 2 divided by the answer. This is negative 1.05. And negative 0.105. Negative 0.105. This is less than 0. Right, so therefore, x, which is equals to 1.30, 3SF, is maximum. Okay. Do they want anything else? Find the x. I'm done. I'm going to run out. This is so tiring. Okay, so what do we have? This one is like Right, so okay. All right, anyway, I mean, it's a line and plane, they're either parallel or perpendicular, or they intersect. We'll see. Okay. So r dot 5 minus 1 minus 11, 38. I can find AB. Right, okay, I'm a bit lazy to calculate stuff. So I'm just going to use the GC. Okay, what? AB is just going to be OB minus OA. OB is 1, 3, 17 minus 08, which is 6, 2, 6. Great. So negative 5, 1, 11. Negative 5, 1, 11. Oh, shit. Okay. Oh, they are same, parallel. Okay, so since direction of R is parallel to normal of pi, right? We have that pi. R is perpendicular to pi. Just spell it. So weird. It marks for this. Okay. There's the negative. I'll just write one line. Sure, parallel. The equation of pi is this, and the slanted cap form. So misleading. Let's say pi lah, you know. Okay, never mind. Oh, there's so much space here. Gosh. Okay, okay, this is a line. Right. Okay, good. Okay, interesting, right? Right, so this is basically challenging you to actually change it to this. Starting principle. The Q itself is okay, they don't really have much numbers here to work with. 1 over 21. Okay, 1 over 15. 1 over 7. Okay, I think this is a time whereby I think I always tell JC2s, not A levels, to really use the GC because look at these numbers. They don't look friendly at all. So GC will be very, very much useful here actually. Anyway, I want an angle between the lines. So required angle equals to cosine inverse. 1 over 21, 1 over 15. Right, there you go. R itself was AB. And then 5, 1, 11, negative 5, 1, 11, negative 5. Okay, oh, this is here. Okay, this is totally not worth calculations. Okay, okay, I'm just gonna count this. I'm gonna capture this correct. So, right, fraction 1 over 21 times negative 5 plus 1 divided by 15 plus 1 divided by 7 times 11 square root 1 over 21 square plus 1 divided by 15 square plus 1 over 7 square. Is change it. The syntax is off. 1 and square plus 1 7 square. Shift it out. Square root of 5 square plus 1 plus 11 square. Okay, this. Let me do cosine inverse. Answer. Okay. Good. This is in radians. We get 45.5 degrees. 1 degree. Right, 1 degree, right? Nearest in degrees. So much space again. Okay. See, coordinates at which Q means slanted height, slanted. Okay. Okay. Q is 1317. Q is R equals to 1317 plus mu. That wants the 21, 15, 7. 1 over 21, 1 over 15, 1 over 7. Slanted plane actually is R dot 5 minus 1 minus 11. 5 minus 1 minus 11. 5 minus 1 minus 11 equals to negative 38. You know what? I'm going to just go back a bit. And in this case, I want to, because R is a 9, so I'm going to add one more part. So my R itself is, since they gave me so much space, it's 626 plus lambda negative 5, 1, 11, lambda real number. I'm just going to say I check for the intersections. So I don't know if it's needed because I haven't really seen what Hua Chong's mark scheme wants. But since they are giving me 3 marks and I have a bit of time, I will just check and I'll just do one more step for it. Yep, just this. And I think it's nice since I was doing a line and plane now, so might as well. I verify 1, 2, 1. Verify lambda is missing. 6, 6 minus 1 to 1 minus 38. So I'm going to just check this thing because I don't find lambda. All right. Okay. So I have negative 38. I have minus 30. And I have plus 2. And I have plus 66. I have 0. Wow. So 626 is on the plane. All right, 30. 626 on the plane. Wow. Okay, so 30 minus 2 minus 66. Okay, it's actually on the plane. Wow. Okay, and they cut at 8 out. Oh, that's fantastic. Great discovery. So therefore R is perpendicular to pi and intersects at 8, 66. Wow, this is probably worth 3 marks, probably. All right, fantastic. Okay. Okay. I don't really want to do this, but I'll give them back the marks. Okay. This is tough because a lot of fractions. Yeah. Very easy to make careless mistakes here, actually, which I don't really like to solve. Okay, never mind. Just finish this. Okay, let me solve this. Okay, this is 5. I'm going to put my numbers in front of this. Okay, so 17 times 11. Don't know what's this. 17 times 11. 7 minus 187. Okay. Plus 5 over 21 mu minus 1 over 15 mu minus 11 over 7 mu negative 38. Pray this number is dying. So weird number. How to have confidence here? Okay, negative 38, right? Minus 5 plus 3 plus 187. 147. Okay. 5 over 21 minus 5 over 21 minus 1 over 15 minus 11 over 7. Oh. Okay, that's quite kind of them. Negative 7. Okay, and 147 is a multiplier of 7. So that is a good news. That is quite a good news. 105. Wow. Mu is negative 1. That's a half number. Right. Okay. Means the slanted. Okay, so I need a coordinate. So therefore C. This is the moment I love the GC. Now mu is negative 105. You can just use the GC. Yeah, clear the screen. So, okay, 1 plus negative 105 times 1 over 21. Okay. 3 plus negative 105 times 1 over 15. Actually, I don't have the times of them. I'm just playing around. 17 plus negative 105 times 1 over 7. Great, enter. Done. Negative 44. Okay, that's quite nice. That's good. Right. Okay. Now, shining a light source on the tension wire rubbish. Okay. Okay, so I have a fixed point at L located above the ground, shown on E. Shortest distance of Q to L. So basically, L is the line. But this one, distance of L to Q is this, right? Okay, so just one this, right? Okay, right. Here is 1317. Direction is 21, 15, and 7. And no multiplier. Okay. L is -6, -1, and 5. Oh, this one easy to make careless like that. Okay. It's okay. Okay. Shortest distance. It's just formulas. Right. It's -6, -1, 5, minus 1, 3, 17. Right. Cross with really 1 over 21, 1 over 15, 1 over 7. Okay, maybe I should put 1 over 5 instead. Okay. Can I just five, 7, 15? Okay, let me just change it to 5, 7, 15. Would it help? Or would the numbers be wrong? Never mind, because they want exact, right? I'll leave it there. I'll leave it there. I will just leave this. I will just leave this. -7, -4, -12. Cross 1 over 21, 1 over 15, 1 over 7. One over 21 square plus 1 over 15 square plus 1 over 49. No fractions. I'm just gonna keep it this. I'll do it this. Wow. Indeed. Okay, this is the last one. Yes. Algebra. Negative. Negative. Okay, I'm just going to use a calculator here. I've already got the square root of 8 square over 35 square plus 9 over 49 plus 29 square over 105 square. And they just have to use the number that's so bad. Wait now. I have this. That's not I did it, right? Oh, this one, right? Square root this thing. So this right by the answer. Oh, 3.39. Units. I mean, I can't give units since I did so much work. Gosh. Meters. Right. I deserve meters. Right. Okay, anyway, we'll move on. Okay, what is this? Yeah, I brought coffee in. It's complicated. All right, so we want the area of the shaded region from Q to R. I think they gave this. Okay. Okay. APQ. Is that even important? They're parallel. Okay, doesn't matter. Okay. But I think one thing we should think of is the graph is symmetrical. So it's symmetrical. And it's 2 pi is alpha. I will just make my life easier. And show this, right? Okay, so I have to make y dx. So the area is to integrate y dx. So the t is 2 theta minus sine theta. I'm just going to write it somewhere here. T equals to 2 theta minus 2 sine theta. And dt d theta equals to 2 minus 2 cos theta. I'm going to make that. So we have to do a v dt here anyway. So okay, my t limits itself would just correspond to the alpha values. So we'll take the t values at q and the t values at r. Right, so that means it will be 2 bracket 2 pi minus alpha minus 2 sine 2 pi, so long. Okay, then 2 bracket alpha minus 2 sine alpha, so long. Gosh, v dt. Okay, they can definitely make it shorter. Okay. Anyway, good news is parametric. I'm going to do one shot. So this is 2 pi minus alpha. This alpha. Actually, this question is very similar to one of the A level. I think it's 2021 or this is 2020. Yeah, one of the questions, same thing, almost. Yeah, as tedious and not so simple. Now your V itself is actually A plus B 1 minus cosine 2 theta. So A plus B 1 minus cosine 2 theta. Okay, dt itself is 2 minus 2 cosine theta d theta. Okay, so now we need to change it to whatever we see there. Okay, we'll take out 2. Okay, I probably need to expand everything out. I don't see how this can be done any nice. So I think, okay, never mind. 2a plus 2b minus 2b cos 2 theta. Wait, let me just change the marker. It's too flat. So 2a plus 2b minus 2b cosine 2 theta minus 2a cosine theta minus 2b cosine theta plus 2b cos 2 theta cosine theta d theta. Oh, lucky, no hit margin. I need to factorize it. So, okay, they have a 3 theta there, which means I need my MF26 for sure. So I need to use the factor formula. So cosine, so I probably need to do this. Or it's cos P cos Q. Okay. So cos P cos Q. Yeah, if I forget, better cos P cos Q here. Cos P cos Q. 2 of it is cos P cos Q. So, okay. So this is B. We'll put this here first. Cosine 3 theta plus cosine theta. This is the back part. This is this. And then no terms cancel out. Okay, fantastic. This one, at least the thing looks correct, actually. It looks correct. So this is 2a plus 2b. Okay, and this is not quite there yet. 2b cos 2 theta minus 2a plus 2b cosine theta. So I factorize it. Maybe I'll just show a bit of the line. So this becomes this, right? And then this became this. Right? Just in case you're a bit confused, then this is this, right? And this one. I think the rest is obvious, right? I still need to continue. Not hard. I think almost there. So this is 2b alpha minus alpha. This is 2a plus 2b. Minus 2b cosine 2 theta. If I put this plus b inside, it will be minus 2a minus b positive cos theta. And this will be b cos 3d d theta. I think that would show. Let me just check. Yeah. Not hard. Actually, just tedious. Very tedious. All right, simplify this. Oh, factor formula. Over addition formula. Sine A cos B plus B sine. Okay. So this is sine 2k pi cosine beta minus cos 2k pi sine beta. This guy always 0. This guy always 1. Why a simplified expression for the nz area of the okay? I'm just gonna integrate this. Integrate this fan. This I must copy the whole thing down. My goodness, so tiring. Okay, 2 pi minus alpha 2a plus 2a plus 2b minus 2b cos 2 theta. So A plus minus, sorry. We'll scroll the mouse. So, oh, so long. Okay, I think there's really not much tricks in simplifying this. But I guess considering students coming to this point of doing exams, they should be pretty burnt out. So to be fair, that's why your time management needs to be quite precise, I'll say. Actually, A-level does have something of similar context, I'll say. And it's not meant to be easy. And you probably will need to have a bit of tenacity to survive such questions. Just got to stay very calm and adjust to the question appropriately. Yeah, actually, time management is a very crucial thing at A-levels, actually. Because if you don't manage your time properly, you probably cannot finish the papers, actually. Okay, so anyway, we of course notice many items. From previous part, I can simplify this. I will just have that, I'll rewrite it, doesn't matter. Okay, I'll just do it again. So I'll just write it. So it's easier for you guys if you are checking or trying to understand how we can do this a bit better. Let's do it properly. So this is minus 2a plus 2b. This will be alpha. This will be plus b sine also alpha, right? Because minus minus plus. And this is plus 2a plus b sine alpha. And last but not least, this is minus b over 3. So here. Something as ab alpha pi. So overall, we find that my alphas, all the trigos will be gone now. So I get 2a plus 2b, bracket 2 pi minus 2 alpha. Of course, if you want to factorize the 2 out, it's really up to you. I don't think it makes a difference. Right. If you want to verify the answers, actually it's possible. It's very, very possible. All you need to do is just let alpha be a number. So like if I really want to verify my answers here, which I guess at A-levels I would have done it. I will do math 9. I probably put like pi over 3, and this is 2 pi minus pi over 3. Yeah. So I have A and B. Actually, if it's exams, I would probably let it be 1 and 2. And they didn't say what A and B is. It's just constants, right? I'll just let them both be 1 actually. So if they're both 1, then it's easy to check, right? So if they're both 1, then it's 2 plus 2 is 4, right? Minus 2 cosine 2x, right? Minus 3 cosine x. The thing about checking, it does give you confidence. Of course, partly also because I already invested this amount of time doing the question. But mine as well, I check, so I can actually guarantee some marks. Even if that day, there's no point moving on if anyone wrong. So I'm just going to check a bit. Oh, it's different. That's sad. Yeah, probably need to check a bit. Where did I make a mistake? 2 pi minus 2. Oh, I have 4. I keep the top part wrong. One of the things about this is you have to check this also. Cosine 3x negative 3 cos x minus 2 cos 2x. That's pretty weird. Yeah, copy wrong. Let me check. Scroll this down a bit. That actually got really funny. 2a plus 2a plus no. Oh, it's 3. Minus, oh no, I got 3. Then this is minus 2x. I pick pi 3, 2 pi minus 3. Okay, that means my answer there has some error. I have a careless mistake somewhere. Yeah, I gotta check this. I'm gonna check this a bit. It's unfortunate. Is it because I didn't prepare this? What was it? Can't be. Okay. I am actually short of something. 2 and minus. Okay. I can't go on with this being wrong. I integrate cosine, I go to sine, I integrate cosine, I go to sine, I integrate cosine, I do 3, 2 minus alpha, 2 pi minus alpha, 2 pi minus alpha, 4 pi minus 2 alpha, 2a plus b minus alpha, 3, 6 pi minus alpha. Then I have that this is always cosine. Oh, this is negative. Oh no, this is negative. Oh my, if this is negative, that changes everything here. Okay, my bad. So this is going to be plus. Oh gosh. And this is plus. Oh gosh. And this is minus. So things don't cancel off. B over 3. Minus B over 3 sine 3 alpha. Okay. That is fine. Okay. So like I mentioned, I will probably make mistakes here. And yeah, here it is. Okay. Wow. So this answer is very long. Huh? So it's 2b sine 2 alpha plus. So just remove this. Yes, I actually did make mistakes. So this would be 4a. No, this is 4a plus 2b sine alpha. This is 2b over 3 sine 3 alpha. Okay, I think with this, okay, all the more I will check. All the more I will check. I cannot afford to get this wrong because I put too much time inside. Okay, so I'll clear this. So what I have is this. Okay, I let a be 1, right? So 4 times bracket 2 pi minus 2 times pi over 3, okay, plus 2 sine 4 pi over 3. Where's that pi? It's 2 pi. Plus 6 sine 2, no, 2, no, right? Just pi over 3, sorry. Minus 2 third Okay, I really hope I get it correct this time. Sine pi. Still an error somewhere. Did I key wrongly? 2.6 minus I can't really troubleshoot this. That means 4 minus 2 alpha plus 2 sine 2. Oh, I see the error. It's not meant to be 4. 2 is 2 pi. So this is the error. I'm going to clear this. Finally. All right, good. So this is correct. Gosh, that was hard. Well worth it, because under the next parts with this, the car of the road reached the max. M and L. What is M and L? Okay, so we need dv dt to be 0. Right. So v itself is equals to a plus b1 minus cosine 2 theta. A plus b1 minus cosine 2 theta. And just check if I copy correctly. And we can take dv d theta. It's 0 plus b. This is sine 2 theta and 2 here. Right. We let dv d theta be 0. So sine 2 theta equals to 0. 2 theta is equals to 0, pi, and 2 pi. Actually, there's more answers. 0 pi, 2 pi. Very a lot more answers. I can go for 3 pi and 4 pi. So theta is just essentially 0 pi over 2, pi, 3 pi over 2, 2 pi. Yeah. But actually, M and L happens to be this point here and this point here. So in fact, those 5 answers, they should correspond to this. So it will just be pi over 2 and pi. Yeah. Because pi over 2 and pi. So I'm going to go with pi over 2 and pi. So my V at M, theta equals to pi over 2. V equals to A, cosine pi. Cosine pi. -1. -1 is A plus 2. Right. Then if theta at L, your theta is pi, your V is 1 minus A. In fact, actually, if you are a bit more comfortable with trigo, you can actually deduce the maximum minimum. Because the thing is, cosine itself is going to be bounded by -1 and 1. So if you talk about 1 minus cosine theta, actually, if you do it slowly or what, you should get 0, and cos 2 theta is B, 2. So you get A plus 2B and A. But that is using differentiation to do it. They didn't really say differentiation, so this is good enough. Right? Now, any answers or otherwise, find the distance covered. And last question, finally. Right, okay, this is covered by M to L. Okay, we got the theta values actually. Okay, since we have the theta from M to L, I'm just going to throw in the theta. Right? Can I just put in the theta? Theta is pi 2, right? Oh, I can't. Okay, okay. So that's nasty. I want to use this, I can't, because if I let my alpha be pi over 2, so I can probably let alpha be pi over 2. Okay. It's not nice. Okay. If you let alpha be pi over 2, you should recognize one thing, because if we let alpha be pi over 2, that's not very okay. So if alpha is pi over 2, I think the sad thing is that Q would just be at pi over 2, which is basically M. And this is M. This is a good news. But then you realize that R itself, right, is 3 pi over 2. And that is actually an N. So that's quite a bad news, actually. Right, never mind. At least the graph itself is symmetrical. It's parallel. I can have it. So, yeah, that's fine. Okay, cool. I'm going to let alpha be pi over 2 and I'll half the answer. So, without further ado, alpha is pi over 2. How do I even copy this now? Okay, so it's going to be 2a plus 2b, 2 pi minus 2 alpha, 2a plus 2b. So the distance equals to 2a plus 2b. Okay, because this is 2 pi minus 2 alpha. 2 pi minus 2 alpha. So it's 2 times pi over 2. I'll just do it properly. Just put a mouse here. 2b sine 2 alpha. Plus or minus? Not plus, right? Or plus 2b. Plus 2b sine 2 times pi over 2 plus 4a plus 2b sine of alpha, so pi 2. Okay. And this is minus 2b over 3 sine 3 pi over 2. Okay. And then final answer must be the better. Okay. What's symmetry? Right. Okay, I'm going to work out the back and top first. So this is just 2a plus 2b pi. This is sine pi is great, it's 0. Okay, then this guy, sine pi 2 is 1. 3 pi 2 is minus 1 over, so you can time it for this. Any more pi is going on? No, this is the only pi. Okay, so I just need to solve this guy. Okay. So this is a plus b pi plus 2a plus b plus b over 3. So a plus b pi plus 2a plus 4/3 b. Okay. I'm going to reward myself by checking GC. Okay. But I check this. So let me just check. So we use pi over 2, right? Okay, pi over 2, please. Okay. 19.2, great. Okay. And a and b is 1, right? So 2 pi plus 2 plus 4 over 3. Okay, I got times 2 because I halved it. Okay. Oh, that was tough. Finally done, right? Yeah, this is good. Okay. I think the whole paper itself, I should have a good 1 hour left. I can try a bit to check. I am a bit not so confident of my vectors. So okay, since I'm actually done with the paper, I'm going to show things a bit of a I'll say nuggets about checking answers. Now let's say this vectors itself, I want to check the answer of a cross product, right? You should realize that you can actually dot to check my cross. Of course, in exams itself, it really depends on whether or not you have the time to check. So if I found this particular vector, 8, 35, I can take 8 over 35, I times -7. So I dot with the preceding vectors. By right, I can verify if my dot product is correct or wrong. So I do advise A-level students to do it now because they do want to actually verify that the cross product is correct. So if you're correct, then at least you can move on with confidence. Actually, H2 math, without the ECF part and all this, the precision is very important. So you can see if I take this 8, 35, 3, 7, this vector here, I dot with this vector, I got a 0. It means that my cross is, I would say 100% correct now. It's 50% correct. If I'm really careful, I dot with this other thing, which is a fraction, and I'm not so keen to check that. And of course, the magnitude part, all these things is good to use the GC to verify the answers. And I'm just going to check if I calculated correctly. This is good. This should be correct. This one, for 2, if I want to check this answer, I would check if my -4, -2, does it dot my plane to be 38, then -38. So I'll probably take -4 times 5 plus -4 times -1 plus -11 times 2. So I get -38. Pretty much shows that no characteristics. Great job. Give yourself a pat. Okay, this one is a bit hard to check. You can't really check this. You can only check if you dot correctly. Yeah, it's a low-hanging fruit, I'll say. This one is also, I use calculator a bit. As for this one is a bit quirky, actually, I'll say. This 5 marks is very interesting. And we can't really plot the graph out. Yeah, it's really very interesting. So it makes sense that dy dx is 0 because it's the max. Yeah, I'll say that this question is really quite fun one. I mean, this graph is fine. Just use calculator. This one we also verify with GC. I don't have to check again. I'm done with this. This one is interesting. Little space. I can verify this. Probably this one you can check her working a bit if you want. I think the one that I want to check is more like the vectors in front because of my fraction. First, I verified this also, so I know I'm correct. Did I verify this? I think, yeah, I did. Yeah. I got 2, right? So this graph is good. See. I probably want to check this again because having 22 over 15 is a bit weird, I must say. So let me just check this. So this is PQ, OQ minus OP, OR minus OQ. And then if I bring this over, it's 2OP, this is 3OQ. I divide 1/3 R plus 2/3 P, that's good. Lambda P, QF is lambda P minus Q. I dot, and if I expand, I got Q dot P. My Q is 1/3 R plus 2/3 P. Expanding gives me this. OR is 3OP, OP square. I will just cancel all my P's. And then I get 4/5, -2/3. I don't see a problem. Is there another way I can do this? If I know that P and R has angle of 4/5, okay. Okay, there's really not many ways to do this. I can, but they want scalar. I guess if you really want to do this question in another means, you may actually draw out and solve it geometrically. I think it's plausible. Yeah, I'm just gonna go with my answer. Yeah, I'm gonna take it I'm correct. I'm not sure too. If I get an answer, then I'll be happy. All right, so this one is fine. It's a show question. I know my marks. And this one, okay, my domain of H, I check the graph. It's this. It's 1, 1. I have the lower part gone. Negative square root 3 lambda. The graph is positive, so there should be no intersection. Empty set is correct. Ln 39. Yeah, we can verify this first. Let me just check this. Ln of 3 times 4 square minus 9. Then this is ln 39. Is that correct? Okay. Let me just check ln of 3 times negative 4 square minus 9. It's also 3.99. And if I plot the graph, let me just check graphically, since we have some time. I probably wouldn't take the full 3 hours. Usually I do it. Y equals to ln 39. Okay, it's not 1 at that. Okay. Right, fantastic. So this is done. And asymptotes 1/4 x equals 0. Spotted. The graph is this. Or it's less than equals 0. So I want it to be negative. This is okay. Ex into x, ex. Inequality is the same, right? On both sides. Cancel. This one. Yes, yeah, for the graph to check the answers. I think I did actually. Yeah, so it's fine. The answers should be correct. Oh, then we are done actually. So yes, and I think that wraps up all this. I think I also told the HCs if you have the paper, you got it back, you really want to ask, I can always bring it down. We can help you. I think all in all, this paper is tedious. I mean, I took 2 hours or ish, so it should be a bit hard actually. I would think the paper is hard. If not, then thank you for your time also. I really hope you enjoy. Maybe it's quite fun to do papers. I mean, I usually do papers once a year at A-levels. Just take it. But been a while since I have done my school. And it's still quite fun, right? If not, thanks for your time and you can go.